So was a division known as core data, which had various pipelines. YouTube data pipelines were there. So we developed an entire multi-agent system which automated the entire pipeline flow. And previously we were doing it manually. There was a config with which the pipeline was created. Then the pipeline was deployed in production. There was a binary for that. So that entire thing was automated using a multi-agent system. So there when we automated it, what we did was we queried the existing pipeline, which we have created manually. So that is, and then we knew that whatever automation we have done using multi-agent system, that is correct because that is following the same result following the same result corresponding to the pipeline which we have created manually. So this is indirectly retrieval augmented generation. Basically, you are retrieving something from a database to verify that the results which your automation workflow has created is correct. So the pipeline remains the same, ML life cycle remains the same, but there is one more addition in the case of evaluation that we are retrieving from some external database. Yeah. Okay. Thank you.
So one more question, Rajat, sorry for that. So
No, no.
here in this entire life cycle, so problem definition, data collection, just like if I'm just comparing with the DevOps. So every phase there will be a new set of tools we can use. So one tool you told like ML flow at the capturing the data DVC. So in every page, is there any tools we can use? Is there any plan in this session? Do you explain that, or is my understanding wrong? Like this entire life cycle will be captured in one tool, or just I hope you understood my question, or should I rephrase?
Yeah. One second. Sorry about that. Yeah. Can you come again once again? So I got distracted actually.
Yeah, no issues, Rajat. So my question is like if I want to compare this with DevOps life cycle, so
Mhm.
every phase I will be having a set of tools
Yeah.
like version control I have Git and the repository I have container registry something else. So
Yeah.
like that for every page I have a different set of tools available in my market or everything I can wrap it in Azure DevOps like that. But
Yeah.
in similar to the this ML workflow,
Mhm.
for every page, is there any open source? I mean, like any tool where we can track or everything we can bind it in one, just like Azure DevOps, like
Yeah. Yeah.
everything.
So
Can we
ML
do it
flow.
in that? Yeah.
Yeah, yeah. The combination of ML flow and DVC does that. So that's what we are discussing till now. That versioning can be done at three levels: data, code, and model. And then finally, even at the deployment stage also, what version of the model you have deployed. So all these three layers we can do versioning because everything is changing. For the data is changing, for the model, the parameters are changing, and then the code which is bounding this pipeline, that is also changing. If you are joining the database or some retrieval external database, then you will need some code for that. So ML flow and DVC together, they can track versioning of all these three different layers.
Yep.
There is no, yeah, we will see how they do like that.
Okay. Yeah. Yeah.
Okay, thank you for that question. Yeah, sometimes you have to reinforce the
Rajat,
create. Yeah,
one more
Rashid.
question on the same line. Like, so in the monitoring phase, right? What all metrics we monitor for, and then is there any specific tool we use?
Yeah, yeah. You can basically precision, recall, F-score. All these are standard ML models evaluation metrics, right? Accuracy, how much. So if it is a classification problem, then what amount of what percentage of objects were classified in class A, what percentage of objects were classified in class B, and then out of those objects which were classified correctly, what is the precision? and there are different F scores also, right? So all those things are done as part of monitoring.
Okay.
Okay. Yeah, now we are coming to ML flow. What are some concepts, right? So ML flow is an open source platform for managing this entire life cycle, right? And every experiment is like a container. For example, in Kubernetes, there is a entire cluster of containers. And suppose there are two experiments running. One is fraud detection, and second is image classification of which is done using ResNet. So every experiment will be stored in a different folder. And then each experiment can have multiple runs. Fraud detection can be run with three learning rates, 0.01, 0.001, and then 0.0001. So that is the difference between experiment and run. There can be experiment is very specific to a particular problem domain, and inside each experiment we can have multiple runs. Okay. And the runs can be varied according to different parameters. Those parameters can be learning rate, batch size, or optimizer. Wherever the problem domain doesn't change, that everything can come in the run. So that's what I was saying, that in the launch approval, you have to show this plan that for learning rate, what all parameters I wanted to test so that I am confident enough that it is working correctly in production. For batch size, what all parameters I want to test so that I understand that for this particular batch size, it was running the best and I'm 100% confident. Which optimizer was showing the best results? I tried various optimizers, Adam optimizer, other optimizers, and this Adam optimizer was showing the best result. So all these are taken care inside the runs. And then what is the metrics, which I think the previous question, the metrics are accuracy, F1 score, RMSE, loss. RMSE is mean square error, right? So root mean square error. So there is something, some term known as cross entropy also, which actually tells uh, the amount of disorderness or the amount of relation a particular neuron does with other neurons. So that cross entropy comes in terms of loss and RMSE also only. So these are the metrics which generally any artificial neural network or any LLM which is based out of foundation block like an ANN or FFN uh, calculates. Yeah. And then finally, there are artifacts, files which are generated out of every run. So whenever you make a run on a particular set of particular value of learning rate, particular value of batch size and optimizer, then you get a certain amount of artifacts. You get a model file, .pkl file, which is basically which will contain the weights of all the neurons, how much it is trained, and then you will have a plots, whatever testing data you have run on that model, how it looks in the plots. And then there is a confusion matrix image which shows the W1, W2, W3, and then feature importance chart. These are all internal representations. If you have if you have converted the words into embeddings, then which feature is dominating in those embeddings. So all these are different types of artifacts which a particular run has. And this is how the UI looks like. You can see there are three columns, run, and then learning rate parameter, and then the amount of accuracy achieved by that particular learning rate. So for the first run, learning rate is 0.01 and accuracy is 89%. So similarly like that. And since everything is shown in a single dashboard, so you can slice and dice. It will give you some filters. It will give you slice and dice. You can, for example, apart from accuracy, there are precision recall and F1 score also. So generally it gives a drop down here which says metric and you can select from accuracy precision, recall, F1 score. Right now, if you select only accuracy, then it will show only the accuracy. And at any point, you can just change that drop down to F1 score, and then it will show only F1 score. So it's an apple to apple comparison between different metrics, and you can compare parameters and you can select the best one. And there are other advantages of MLflow that you can log whatever model you are committing, and you can again reinstate the older log, older hash, and reinstate it. Yeah, and environment also. So in Python, you have to configure an environment, right? Conda environment or something like that to run your model. So all those information goes into the commit, and that can be stored by the MLflow run. Yeah. So it means that whatever configurations were varying in different runs, those are stored at a proper place in a folder, and those folders are used by MLflow to generate the dashboard. And you can rerun the exact same configuration again using that folder, parsing that folder and running it. Okay. Okay. I think we are nearly approaching the installation. Yeah, so this is where, yeah, Ashish, go.
So, Rajat, two things, right? So, one is uh, obviously these slides are very helpful, but it may be a bit overwhelming to absorb a lot of details because they are theoretical. I mean, it will be easy if we can do the hands-on and see, right? Because I mean, it will be easy to connect the dots, right? If you do hands-on. And second is MLflow uh, is a great tool, right? But I mean, if you can also give us some pointers with regards to what tools are more popular, right? So I think MLflow is mostly used for experimentation, though it offers the flexibility to basically deploy the models as well. But in my organization, usually people use GitLab, um, and I mean, it is just for you so that you can tweak the learning plan for us. That is one thing. Other thing is, um, I mean, the large scale organizations are able to basically fine tune the model, right? Largely, I mean, in banks or in service industries, I mean, if they are not very big product techie companies, they do not go for the model fine tuning because it is pretty compute heavy, right? We do not prepare the SLM of our own as well. So, um, I mean, it is just a pointer so that you can basically take the learning plan. So we will not be probably not be very much interested in fine tuning the LLMs, but we will more be interested in agentic application development on from deep learning side and for machine learning side. Obviously, the end-to-end workflow.
Yeah. Right. Thank you. Thank you for that, those inputs. Okay, so what we can do is we can start MLflow installation. I know that this theory is going too long. So so all of you are using Windows or you are using Linux also in some cases.
I am using Linux.
Okay, so you need to figure out the commands for Linux installation of MLflow.
Okay.
So what I will do, I am
So
using
what
Windows.
about Mac? Is there anything?
Yeah, Mac also you will find out. You will be able to find out on internet that how to install MLflow. So what I will do is first we will walk through the Windows installation. Okay. And then let's make sure that everybody who is using Windows, it is working for them. And then we'll jump into the Linux and Mac installation also. Okay. S- So these are the basic 6 steps by which you install MLflow. Right. First of all, you open a command prompt and you create a new environment. So the environment is created. Now you have to download this script. So ML flow installation, if you search. So you need to make sure that your Python version is greater than 3.8, and then you can use command prompt PowerShell. And then you need to create a new environment and then activate it. Yeah, this particular. So once you activate, then you can install MLflow. So when you create the new environment, you will see the activation script here.
How was that you on
Sorry,
that we are all aware of how to activate the virtual environment.
you are all aware. Okay. So so then you can just install MLflow like this.
You did not activate the environment. You are not in the environment yet.
Yeah, yes. Just a second. 1 second, I'll be back. You can just use this commands. Zero. And when you will run MLflow, then it will start the local server and it runs on this. So is everybody who is using Windows is able to follow like these steps? And then, yeah, if you want me to go slow, like you can take a break. Because we have already gone continuously for last 70 minutes. So if anybody wants to take a break, but generally these are the commands for Windows. And you will see
What you did to activate this?
like we ran this script MLflow. So as soon as this new environment is created, then you run this executable script, activate. So after running this script, there will be something like this, which is shown, which is a virtual environment. Okay, so now it is complete. You can check it in this. So this is your local ML flow. Till now, I've already run a lot of experiments, so it is showing different types of experiments. Within the experiment, you will see the runs also. So these are different runs. And you can group by. You can see the graph also here. What are the accuracy of different runs? And there is models. Okay, so I would encourage all of you to install it. Then we will do some maybe we'll run one experiment on it. So once Windows is done, then let me know if you want to do the Mac and Linux one also. Yeah, we use Conda to create virtual environment, then activate it. Then we install same by using same pip install. Then we run the server using the host and port parameter. Then yeah. Yeah, so as we discussed, right, like every run is a folder. So that folder can either be stored in a file-based tracking or it can be stored in SQLite also. In Mac, it is showing that you can configure MLflow to use SQLite as the database to store all the metadata. So yeah, let me know.
So Rajat, after running ML flow, we are supposed to go to the browser and type in that IP where this is getting
Yes. This is yeah. This is the IP 127.0.0. Post
Okay.
here.
Just one query here. Suppose if I have already done this ML flow installation and setup for some other project already, so do I have to do it again so that I can use it in a I can make a separate folder and now work on a different project, or I can do it in the same folder that I have created earlier by using this ML flow virtual environment creation.
Yeah, virtual environment, you can use the same. But if you want
Okay.
to run more experiments, you can create another experiment. You don't need to do the entire setup again.
Okay. Thank you.
Yeah. For example, when I did pip install, it already always set requirement already satisfied because I've been